We'll wait for another minute. We'll wait for 2 more minutes until it's 2. Okay, welcome guys. Today we'll be talking about some basics. So some of you, especially those with a traditional CS background, will not find today very hard, but I hope there's a couple of nuggets at least for everybody in here. And so what we'll be covering today is, we'll be talking about how to use Git, what is Git, what are different version control approaches, and why are we actually using Git, or why are so many people using Git. And then we'll talk about everything you need to know to successfully complete the first homework, which is in this case HTML, CSS, and SVG. And so I will not give you an introduction to how to properly lay out or build nice looking websites with HTML. We'll be looking at the structure and at the rules essentially of how a DOM is created, how we can select elements, and then how we can draw elements with SVG. If you want to follow along, everything here is interactive. So the first part is in my console, but all of the other parts are interactive on the website. So you can you're encouraged to bring out your computers, to type along, to play around with different examples and so on. And you can go to this website, databasescourse.net/tutorials. This is where you find all the content, which is also where you find content for future lectures and labs. Okay, before we start, any organizational questions? Homework 1 is out, it's due this Friday. Please submit via your Canvas Dropboxes. Everybody is probably aware of the late day policy, so you can submit at the latest Sunday night, but you would lose 20% of your marks. Okay, so let's get started. Let's talk about version control with Git. So why do we want to use version control in the first place? Anybody have any opinions?
When you work on a particular piece of code, you want to create different versions and a new, better version comes around. Supposedly, let's say, an issue with a new version and we want to go back to the previous version.
Yeah.
It's much easier with the Git or any other version control like this.
Okay, but why don't they use something like the history feature in Google Drive or Dropbox?
Because here you have options of kind of creating different branches, and let's say there are different teams working on different versions of the code, so you can easily move back and forth between different versions.
Exactly. So essentially version control lets us do things like synchronize between a team, keep versions, keep histories, do branches, and so on. So we can first keep copies of multiple states of files. We can create alternative states if you want to test out a new feature, or have a stable branch of a piece of software that I'm developing and I want to implement new features. I don't usually do that in a stable branch, but I would rather have a develop or like a feature branch. It's about collaboration too. It's really, really terrible to do collaborative project without using proper version control. Like the worst case is probably sending code around in emails. The second worst case is probably using Dropbox, because you will be writing at the same file at the same time. You will have conflicts. These will not be moderated in any way. One thing that is especially important for people who are working on their homeworks or projects is it keeps your work safe. If your computer gets stolen or crashes, if you regularly commit to a version control system that is on the internet, you automatically also have backups. And then finally, you can also share what you're doing with the world. You can elicit feedback from other developers. This is like how open source communities work, and GitHub has a lot of really cool features to support this. So there's two major different types of version control. There is the central repository approach, which is kind of like the one that I used a lot when I was in grad school, where we have things like Subversion or CVS. This has like a classic client-server model. So here the green node corresponds to the server, and like one server stores the code for everyone, and it stores all the version, and I only give local copies. So everybody needs to write to one server, and all operations like history, commit, or branches require a server connection. This is like, as I already mentioned, a traditional model, and one advantage of it is that it's a pretty simple model, right? I have like one more complex implementation, which is the server, and then I have clients that communicate with the server. However, it gets pretty tricky to manage for larger and for community projects. For example, who is allowed to write to the central repository? That's a big problem if you have a bigger team. Or if you're like developing a project in GitHub, you don't want everybody to have write access, right? You want people maybe to have read access and to give them the possibility to make suggestions. That's not, of course, not impossible to implement in a centralized version control, but it's uncommon. And then how do you apply changes that somebody outside your team made? This is not clear how you would do that properly with central repositories. The distributed version control system is, as the name already says, like a distributed approach. Here, every node has a full history of the repository locally. So every, like if you're using Git, for example, you don't have a dedicated server. Every node is conceptually and technically at least equal. In practice, we still often use a server just as a convention, but this is like really just a convention. Your local copy, everybody could pull and pull from your computer and push to your computer if that is enabled, equally as for the GitHub servers, for example. What are the advantages of that? We don't have any access issues. I can make a local copy, have all of the history here, and I can hack away. I can also very easily ask a partner if they want to accept my changes. So I can point them to my repository, tell them, hey, look at what I've done, and if that is satisfactory for them, they can simply pull from my repository and merge with theirs. The other advantage here is also that everything is local, which means that it's fast, or almost everything is local, and you don't actually need internet connection to commit, for example, to work essentially to do software development. And this also emphasizes the commit often model. If you commit to a server, if you have tests running and so on, you might actually break something. But if you work with your local copy, you can actually commit very often. And so what you should really do is you should commit once per feature. When you're working on something and then you're done, and before you move on to the next thing, simply commit. This doesn't mean that your friends have to synchronize or anything like that. It just keeps a very clear history of what is going on. What are the disadvantages? Well, it's a more complex principle, it's harder to implement, and there's a couple of additional concepts that we have to learn, specifically the extra effort to distinguish between committing and pushing and pulling. So, just like a show of hands, who's used Git and GitHub before here? Okay, the majority. This is really changing fast. 2 years ago, this was like maybe 50%. So implementations, I already mentioned some, CVS, SVN, and distributed would be Git or Mercurial, and we'll be using Git in this lecture. So Git was created by Linus Torvalds in 2005. It's British English slang, roughly equivalent to an unpleasant person. And he essentially equates that to him, like I'm an egotistical bastard and I name all my projects after myself. First Linux, now Git. And so why would we use Git? It's pretty popular. This number here is a little old. I would guess that nowadays it's probably more like 70% of all open source projects use Git. It is very distributed, it's truly distributed, it's very fast, everything is local, it's free, it's safe against corruptions, and of course there's also GitHub. So let's just look at how Git in general works. So let's say I start with a local copy, I create a repository, then I write something to a file, and then I commit something. Okay? So this is like my commit. Then I do something else, this is like time here, and I commit again. Now I want to make a branch. Let's say this is my master. And then I create a develop branch. Okay? And so now once I create this branch, what I do is essentially like I make like a copy, I create a new branch. It's actually more like this. And now these two versions are exactly the same thing. Now I can start editing here. So these are two new features that I'm implementing, but then I switch back to this other branch and edit something here. And now what happens when I want to synchronize those two? I simply this in the develop branch. What I would do is I would first catch up with what has happened in the master branch. So I would create like a merge node. Here, like this would take the information from this commit and combine it with this commit, and then I can, if I want to, merge it back into the master. Okay, so now I'm again on the master, and this here kind of like is an implicit node, but it's essentially like merged like this. So if I wanted to like now have a server is very much just like another branch. If I have like say a remote here. Conceptually, all I'm doing is I'm pushing this to the remote. And then somebody else could have like another branch. And this, of course, contains all of the history here. And then somebody else could come in and have like a copy of this remote, make their changes and so on. And this would work very similarly to what we've seen here. Okay. So, the rest of this class, or the rest of this part, I will simply be typing. Many of you probably use some graphical user interface clients for GitHub. I find it more, let's say, explicit to use command line tools, but you're of course welcome to use command line tools. So first, you should always configure your repositories. Please make sure that your Git. Please make sure that you properly do that. This is especially important because we care about who is contributing to your project. So we'll be looking at your final project, we'll be looking at your repository, and we want to understand who is writing which part of the code. And so to properly set this, please use your proper name and a Utah email address if you're working on your project. So I've already created a folder here, and now to initialize a Git repository, I simply type git init. And so now I've initialized an empty Git repository, and what we want to look at is what is going on here in this repository. So what we see is that we have like one hidden folder, which is the .git folder. If we look at what is in there, we can see that there's a couple of different files and directories. The really interesting part here is actually the config file. So if we do git config, we can actually look at how is this set up, how is this configured. And this is like a very simple, I only have a single branch, I don't have a remote, so this is a very simple configuration file. Here's an example of a little bit more interesting configuration file. Here I have a remote origin, which is a GitHub repository, and here I have the master branch of my local copy. Okay, so when we create a file, Echo simply just outputs something to the console. And then this greater than sign simply writes it to the specified destination. So now I have created a demo.txt file, and I can look at what is in this demo.txt file. There's hello world. So let's add it to version control. That's very simple. Git add demo.txt. Okay, let's look at what this does. Git status gives us the status of this Git repository. It tells us we are on branch master. This is the initial commit. We have a new file, which is not yet committed, but which is essentially staged for commit. So, so we've added this file, but it's not actually a commit. So I could add multiple files and then later commit. So what I'm doing now is I'm committing. Commit -m. You can also not use the -m, that'll need to drop into an editor. This is just a commit message. Committing the test file. Okay, so we see that this file is now committed. We are on branch master. There's nothing to commit. The working tree is clean, and our file is around here. Okay, so now we change the file again. And by these like double greater than signs, I'm appending something to the file, demo.txt. And now if we look at this, we can see that we have these two lines in here. If we look at the status of Git, it will tell us, okay, there is a modification happening. So what happens if I commit now? What happens when I run this line?
Not working.
What's that?
Not working.
Yeah, it will not do anything. The reason is that you always have to add a file. Like even when you change it, you have to re-add it. So you can do either git add demo.txt, or you can do what we had here, git commit -m, and then add a -a. And this simply auto adds all of the changed files. So this is like the command that you would use in a typical scenario to commit any changes that you made. Like what often happens is that if you use this command, you forget that you have added some files, and then your code on the server will break and so on. But that's another story. Well, wrong order. Okay. So what we can also do is we can look at what has happened here. Like this is the log of everything that we've done to this repository. So next we'll create a branch. I'll call this branch draft. Okay. Now we have, if we type in git branch again, we can see that we have now two different branches. One of them is the master. The other one is the newly created draft branch. And then the star here indicates that this is the branch that I'm currently working on. So if I want to switch the branch, I say git checkout draft. And now I've switched to branch draft. And we can see that the demo file is exactly the same as before. And now, now let's edit something. So I'm adding a line here. Okay, now I have 3 lines in this file. I'm committing it. Okay. And now I've written those changes to the branch. If I again check out the master, and now look at the demo file, I still only have the 2 lines. Now let's do something else. I'm adding a line at the beginning and one at the end. Saving this, and then committing. Okay, and now the interesting part happens when I want to merge back. What is the problem now if I want to merge back? I've changed the file in two different versions, and so if I say git merge draft, I will simply get a message that I have created a conflict. So let's look at that conflict. What we can see here is that we have this new line here was automatically merged. So this is not a conflict. This was automatically added here. But here we have in this place, in this like third or after this are you still spinning, there's 2 different versions. And so I can either choose the one or the other. In this case, I want to have both. And now I have resolved that conflict. Manually, of course. And that is it, basically. Okay, so this is like just raw Git. Any questions about that so far? Great. So if we want to work with GitHub, now let's set up a new repository. Calling it demo. And then I'm initializing it with a README, and then you should also add a git ignore for that essentially just make sure that like files that your IDE creates or something like that simply are not committed. And now I'm creating this repository, and then I can very easily clone that. And so this clone now retrieves this repository that was initialized on the GitHub server to my local computer, and now I have a demo directory. And in here I have the README, but nothing else. Okay, so let's write something here again. And add the file. Okay, and so at this point I've only committed something to my local repository, but GitHub at this point doesn't know anything about that yet. And so what I have to do is just to synchronize this with the server is run git push. And git push is kind of a shorthand. If we look at our configuration file, we can see that we have this remote origin. And this is kind of the default. If we just run git push, this is where this is pushed to. Okay, so what we've done here is we have written this to GitHub, and now we can see that this file has appeared here, and we see that it contains hello world in here. So that is pretty simple. If we want to make a change to that, we can use I'm kind of simulating that somebody else is making a change here. I'm editing it directly on GitHub. And now this is changed remotely, and what I need to do to get these changes is to run git pull. Okay, now if we look at our local file, we see that there's one line was added to demo.txt. I can look at this, and then I see how is it going, which I've just done on GitHub directly. So this is very similar to the merging and branching principle. So Other GitHub features that I would recommend you use for your project are GitHub issues. It's really good to keep track of what you're doing. You can also address these issues directly out of commit messages. So for example, if you're working on a bigger feature or on a bug fix with multiple commits, you can always say working towards number 14. That means you're working on issue number 14, and you can also directly close an issue out of a commit message with like fixed number 14, for example, as a commit message, which automatically closes that issue then. And then the other important GitHub principle is forking. So for example, if I publish a repository on GitHub, somebody else can fork it. That essentially means they create a local copy. They have then off their local copy, they have full control. So they can edit whatever they like, they can share it with whoever they want. And if they at some point later want me to reintegrate their changes, they can submit a pull request. And then I can review their pull request and decide whether I want to accept their changes or not. In terms of graphical user interface clients, there's the official GitHub desktop client, which is a good option if you really want a GUI client. You can download it behind this link. And then many IDEs have also version control features integrated, for example, WebStorm. And so here's now like a short introduction on like one workflow that you can use to update your homeworks and to automatically like save your homeworks on GitHub. So here, like as you know, the homeworks are published in this repository here. And so you see there's homework 0 and homework 1. And what we do is we simply clone this. So now I have all these files. Oops. So now I'm in this repository. I have the homework 0 and homework 1. And now what we can do is, well, I did something wrong here. So I need to set a special origin here. So minus origin homework here. If I run this, I'm not setting like the default origin. This is now like this is a special origin that's called homework. And what we can do by that is we can now push this repository to your own to your own GitHub account. So let's say I'm creating a new repository. Okay, now I've created an empty new repository. And I can now add that as a remote origin. So that's git remote in the repository, of course. Git remote add origin this URL. And now I'm pushing this to my local repository of the homework. So now, essentially what I've made is I have now one repository on my GitHub that has that points to two different repositories on GitHub. One of them is the one we control, where we publish homeworks, where we release updates to maybe if we find a bug in our stubs, we will release those. And if that happens, or if we release a new homework, all you have to do now is git pull homework master, and that will get all the new changes that we have added to the repository, and will automatically merge them into your solution. So that is like a recommended workflow. Of course, you can simply download it and manage it in any other way. For the homeworks, we won't care. For the projects, you of course should use a Git-based workflow, or you have to use a Git-based workflow. Okay, so that was everything that I wanted to say about Git and GitHub, and now let's move on to HTML.
Can I ask you something?
Sure.
If if I create a repository on my account of GitHub, how do you know where to find it?
I don't. This is so. There's two different things. For the homeworks, we're never looking at your GitHub repository. It's just like a recommended way because you will have to use it for your project. For your project later, once you have found a team, you will have to fill out a Google form telling us all your team members' names, your email addresses, and then your shared GitHub repository for your project. And that's how we find out where your work is stored.
Okay, so we always submit on Canvas?
For the homeworks, yes, you submit on Canvas.
Okay,
Yeah.
thanks.
Yeah.
When will project collaboration start?
You can start as soon as you want. The deadlines are already on the calendar. I would say it is like you can start thinking about it. You can start finding a team. Really starting to work on the project is probably sensible after, let's say, homework 4 or 5, because by then you will have the necessary skills. Any other questions? Great. So, let's talk about HTML. So HTML means hypertext markup language. Nowadays it's more of like essentially how do we render things on the web. We'll be using the HTML5 standard, which does things like graphics, audio, video, SVG, and so on. So this has changed a lot. HTML5 is very, very different from HTML4. Another interesting part of HTML5 is also that it's not XML anymore. So there's HTML, but it's not the proper HTML5 is not an XML dialect anymore. So there are some relaxations in there, which I'll be talking about. So the most important parts of HTML are, of course, elements. And these elements, like I have text. And before I actually talk about this, like these are these interactive boxes that I mentioned. So I can type something here and see it added to the next to the window below immediately. I know that there is somewhere here a bug, so some of you might only see 2 or 3 lines or a part of, like if these boxes get longer, like here, sometimes on some browsers not everything is shown, only the first couple of lines are shown. And so what you need to do here is like simply click somewhere, hit a space once or change something else, and then that should appear. It's like if in case you're wondering why what I'm showing you is not what you're seeing there. Anyway, so whenever I make an edit to any of those attributes here or any of those code boxes here, it's immediately reflected on here, which is very similar to what we see in JS Fiddle and so on. You can always also click at the see output in new page. This doesn't take this is actually a broken link. Great. Anyways, when I fix this, you can always look at just this web page and not at any of the other web pages, which is convenient if you want to debug your code in detail. We'll talk more about this. Okay, so elements. Elements essentially tell like we can do very many things with elements. We'll talk about them. Here we have a strong element. That means that the content between those elements has these properties of the tag applied. In this case, it's simply rendered as strong. You can see that the rest here is not rendered as strong. So we can also nest these elements. This is a strong part, and then here we have an underline and strong part because we have this underline in here. Then in addition to just the tag names, the element names, the opening tags can contain extra information about the elements, which are called attributes. So the common one that you probably have seen many times is this href attribute, and now here this is like a link address, and then this is rendered as a link to Google's main page in this case. So this is pretty simple. href is HTML reference. The types of attributes we'll be using here mainly are things like IDs, classes, and styles. These are the ones that we dynamically want to, like IDs and classes, we'll talk more about them when we talk about CSS, but they essentially help us to identify elements on a website, and we want to programmatically like label elements on a website and then programmatically retrieve them at a later point. The difference between the ID and the class is that the ID is supposed to be unique. So if you actually have more than one ID element, this is not legal, and the class is something that you can reuse. So you have like multiple different classes of a certain element. You can use self-closing elements. For example, here, like this looks like that. This is what people that wrote HTML4 code used to do a lot. So there are certain tags, like the break tag, that doesn't have a closing equivalent. And so what you needed to do is you would need to write something like BR space and then slash and then close the tag. So something like this. This is, however, no longer necessary in HTML5, since this is no longer an XML-based language. It is perfectly legal just to use a break like this. So there's no requirement to have closing tags in HTML5. Here are some important tags. I'm not gonna, this is not particularly important, but let's just revisit them. We have HTML tag, the head. This is essentially defines what is shown in the browser title here. And then we have the body, where we have paragraphs, paragraphs of text. We can break lines with the break symbol or with a non-closing break tag. Either is fine. We can include images. If you use images, you should always provide an alternative text. This is mainly an accessibility feature, so that people that use screen readers can understand what the image represents. Then we have headers with H1 to H6. We can have lists. We can have ordered lists or unordered lists, and these are the list elements. Also note that you don't actually have to use closing tags anymore in HTML5. So this is perfectly legal here to simply say list and not have a closing tag. I personally, it looks wrong, but it is absolutely legal. Here's an unordered list. Here's a table. And yeah, like table rows, table headers, table datas, and so on. I'm sure you've seen this before. An important element, or two important elements that we use very often to structure HTML are divs. Divs are simply like dividers or divisions of a page, which are often used to provide structure to HTML. These are block elements, so they break lines. And if you need something to identify a subset of the code, but don't want to break a line, you can use the span element. So if we look at this down here, so here this is in a div, and this one is in a div, and that's why here there's a line break. But here we have a couple of spans, but they don't break a line. This is like depending on what the desired behavior is, you should use either the one or the other. And then there are things like forms, which we might be using, and we might be listening to events and so on. You can of course do comments in HTML with this syntax here, and then you need to close this and close the body and close the HTML. And so what we can do now is we can look at whether this is actually legal HTML code. So we can either put a URL in here, or I can just paste the code. This is the World Wide Web Consortium HTML checker, and you can see that this is a legal document. There is only one warning that I shouldn't use the border attribute for the table, which is a styling thing. It's still legal, but it's essentially not encouraged. I've still done it here because we want to see the table down here. But that's obviously something that you would rather do with CSS. Okay, a couple of other tags that we'll need. We've talked about HTML head tag. We will use the script tag to include JavaScript. We'll use the style tag to include CSS. We'll use the link tag to reference external documents. So here we have the relationship attribute, we have the type attribute, and we have the actual link attribute that we need to specify. And then we've already used the body tag here. And so this is essentially like a minimal boilerplate that we have to have a proper HTML document. And I'm mostly using proper HTML documents from now on. So you should be able to copy and paste them in any way. Okay, so this is the introduction to HTML. One thing that I wanted to emphasize is that the relationship between the document object model and HTML. Who can explain the difference? So the document object model is essentially what is rendered in the browsers, like the tree that of the HTML code that we can look at in the browser. So we can, for example, inspect the source code of any website, and what we see here, like in this Google Developer Tools, is the DOM. In this case, the DOM, like we're not using any JavaScript on this website. So in this case, the DOM corresponds pretty much exactly to the HTML that builds that website. But the DOM is also an API. So the DOM has certain functions that I can access via JavaScript, where I can dynamically modify the DOM. And that is what we'll be doing a lot in this class. So if you've used things like jQuery or simply the standard API or D3 before, these are all methods to programmatically generate the DOM from code. So you can start with an HTML document and take JavaScript, modify that HTML document essentially virtually, and when you do that, it's called the DOM essentially. Okay, great. So next we'll talk about, any questions about this? Okay, next we'll talk about CSS. And again, we'll not be talking about how to style things, but what I really care about is selectors. There's a couple of different selectors. Like here's how you would use CSS. This is like in the style tags. And so we are now here using an element selector for strong. And this is like some styling information. I'm setting background color red, font size to 300%. And then down here, I have this HTML, and this is the part that is in the strong tags. And therefore, this element selector here matches to the strong element. So if I added another strong here, we would see that this matches equally because it matches this tag. And that's pretty simple. Yeah, so everything inside the curly brackets here is the declaration, and we always have the syntax of like what do we want to change and what is the value of it, and then like the semicolon to terminate a line. We can also do things like that. We can separate that out, and if they're not conflicting, both of them apply. If those are conflicting, the most recent one applies. So we can spread that out in some way. Then the very important one is the class selector. I already mentioned this about the class attributes, and the class selectors are identified by a leading dot. So for example, something like dot menu. So here is an example. I have 3 divs with classes. This one is important, this one is footnote, this one has 2 classes, important, footnote. And then I'm styling important to have a bold font weight, and then footnote to have a 75% font size. So that's what I'm doing to this. And as you can see, like this one here has a bold weight. This one here is only 75% of the size, and this size, and this one here at the bottom is both an important and a footnote, and therefore it's bold and only 75% of the size. So that's pretty simple, and I can reuse these classes as often as I want, of course. In contrast to that, we have CSS ID selectors, which are identified by a leading hashtag. So hashtag header, for example, or hashtag ID name. So let's say we have here something like first line, second line, and important. And important is not a good ID, right? This is a much better class, but here, for the purpose of this example, that's fine. I'm specifying those with the ID attribute. ID first line, ID second line, ID important, and then we can see that these are actually applied based on these IDs. So we have font white bold, color blue, that's the first one, then we have a little bit increased font size for the second line, and then some beautiful red text shadow for the third one. So what would happen if I do this? You see what happens. Is this a good idea?
No.
No. That's fine to do with classes, but this is not valid HTML5 because IDs are supposed to be used only once per page. And so IDs are kind of like global variables. So you should be using them sparingly, but they of course have their place. anything else you wanted to say? No, I think that's basically it. You can use, for example, IDs in CSS to create the layout of a page. So what we want to do is we have like a menu div, then here we have a main content div, and then here we have a footer div. We don't like traditional or in HTML4 and before, this was usually done with tables, and that's of course discouraged now because it's going to make your life a living hell if you want to port to mobile. But if you do it like this, you can dynamically control your CSS. And here is like just some simple example, like I have the sidebar ID for this navigation element, then I have the main ID for the main content element, and then I have the footer ID for the footer element, and then I can place them by using CSS here and by using ID selectors. Another thing that you might not have come across too often is relationship selectors. So like we've selected based on elements, based on IDs, and based on classes, but we can also have more complex rules on what matches a selection. That is essentially something that can be interesting if you work with D3. So for example, here is a child selector. That means this matches every bold element that is directly a child of a paragraph element. And here we have a descendant selector. This matches every bold element that is somewhat like a descendant at some level of a div element. So this is a direct child. This could be grandfather, grandson relationship, that would be fine. So how does this look like in practice? So here we have this direct child, B of P. Here's the text that this is bold within the paragraph, but then I'm adding a span here, and then with something bold here has a highlight, but it's not going to show up in blue because it is not a direct descendant. It's not a direct child, but a multi-level descendant. In contrast to that, down here I have the same thing, a div and then a span and then a bold text, but I'm applying this div B is a descendant selector, so this is going to be rendered in green. Okay, and so the other thing that if you have multiple conflicting rules in CSS, it can be pretty tricky. The rule, like specifically in the standard, is that the most specific CSS will be applied, but it's really hard to tell. So the best approach to resolve those problems is to do some way of debugging. And then we can also, there's a couple of other ways of declaring CSS. What we commonly do is we use a separate style sheet. So we simply include a reference to a separate style sheet and then have all of our CSS in the separate file. We can also directly embed style tags in any of those elements. This is generally, like especially if you write raw HTML, that's rather discouraged. But in practice, if you computationally by using JavaScript create something like that, you kind of like abstract it away at a higher level. So for automatically generated DOM elements, that is not completely unacceptable. Okay. So the last part that I wanted to talk about code today is scalable vector graphics. And so scalable vector graphics, we've only looked at textual content in HTML, but what we now want to do is we want to look at how we can create visualizations, and we can use the SVG standard to do that. So SVG is a subset of the HTML5 standard that will essentially allow us to draw everything that we need. It's very powerful. Illustrator can export to it. You can include SVG elements and images in modern browsers, and so on. And it's also the preferred target for D3. However, this is, like, strictly speaking, not necessary. D3 is just like a DOM manipulation language, and you can do whatever you want with it. But in practice, we'll be mostly using SVG. So here's our very first SVG element. So what this does is it simply creates an SVG. We have to define the width and the height of the SVG. So it is essentially a rectangle. But of course, this is empty. And we don't see anything, and this link is all going to be broken, but let's just take a look. No, this works. So we can inspect, and we see that there's indeed an SVG element in here, but I get an empty one. Okay. So now we'll add a circle. We'll add a circle by simply using the circle command. We define the center X position, the center Y position, and the radius, and then I'm here also defining a style. And please note that the CSS style that is used for SVG is not the same. It sometimes overlaps, but sometimes it does not, as the styling, the CSS styling that you would use for HTML elements. So these are different. For example, there is no fill element in CSS for just like regular HTML. Okay, and so what I do by this, what I get here is a circle at position 200, 100 of radius 50. We can look at the coordinate system here. We have a coordinate system that starts at the top left. So if we go to 0, 0, we'll see that we only see a quarter of the circle. A coordinate system starts up here, and we have to position according to that. Ellipses, just as easy. We have a center position in X, a center position in Y, an RX and an RY, so how high, how wide, and then again styling it, very simple, is basically the same thing. Then we have rectangles. For rectangles we define an X and the Y position, a width and the height, and again we style it in some way. And again we see our rectangle here. Like if we make it a little bit narrower, we can see that we have essentially a bar chart, and then we can add multiple of those to create a bar chart. We can create lines, either individually or with the path element. I'll talk about the path element later. And in your homework we'll ask you to use both. So here we have a line. We simply give it a class here just to illustrate that I can also use this CSS class-based styling. And then I have an X1, a Y1, X2, Y2 position. The same for the second line, and you can see this is like a line from 3030 to 280. And if we go to, let's say, 150 or 50 and 80, this is how the line changes. And again, all of this is in the coordinate system that starts at the upper left corner. We can also add text. The text can also be positioned, or is also positioned with X and Y. We simply, like here, we could do something like this. Of course, that could be done in HTML too, but that would be, well, not very intuitive. So text elements, X and Y position where the text starts. The path element is a little bit more interesting because, like, up to this point we've only used basic shapes in SVG, but with the path element we can create arbitrary complex shapes. And so the path element has like a mini language, and this is the mini language here. And so the most important element here are M, L, Z, and Z, and C. M essentially moves, like think of it as if you're trying to draw on the blackboard, by M I move my pen without putting it down on paper. So essentially here I'm moving to position 1010. And then by the L command draws a line from the previous position to the position specified. So if I look at this here, I have M 1010, so moving it to position 1010, and then from 1010 I draw a line to 5010. So this is this segment here. From 1010 to 5010. If I, for example, change this to 0, 0, this starts here at the very top. I have to have the M though, like it doesn't work without the M. So it doesn't make any assumptions of an initial position. So from there on out, I can essentially keep drawing in these positions, like 250, 50 to 150 and so on. These are all absolute coordinates, so that's easy to do. So like simple lines are easy to do. Here then I'm using, well, so before I do the more complicated thing is I could also add a Z in here, and the Z would essentially tell the SVG element to close the path. And now I could use a fill, and then I could have like a filled polygon, for example, of an arbitrary shape. If I don't close it, we simply have this line segment here. Okay, and now let's talk a little bit about this C, which allows us to draw curves. And so what this C command does, it draws cubic splines. And cubic splines need a couple of, a slope, a slope, then a support point, and a terminal point. And so the first thing here we specify is the slope. The second thing we specify here is the support point, which I'm highlighting here in red. And the third point here is the terminal point. So we have this C, x1, y1, x2, y2, and then x and y, for example, as our terminal points. And so if I were to change that slope in some way, let's say I want this to be steeper down here, you can see that this now points further down and going through that support point. I can make this more radical and so on. So I can modify that spline here dynamically. So in practice, this is not something that we will do by hand much. There are these line generator functions that D3 has. So we'll put in a data array, some transfer function, and then get out a path, or essentially the code here for that, and then use that for the path element. But it's still good to know, and there's a lot of other things that you can do in this by looking into this Mozilla path tutorial here. So this is like everything that I'm showing here, and much more is explained here, how the effect of these different parameters, how they play out, and there's other types of splines and so on. Generally, if you look up anything while you're doing SVG, JavaScript, or whatever, I would always recommend to use the MDN web docs instead of anything else, because they're kind of the standard. You shouldn't use this W3C, like the thing that comes up by default on your Google search is usually not the best. I would, every time you submit a query for some kind of HTML, CSS, or JavaScript question, I would always add MDN, because then you get the right resources. And I'm also adding like a lot of links into here. Okay, so next we of course have to worry, if we draw, we have to worry about ordering. So here we have two elements that have two different orderings, and the different orderings is of course very important for how they are represented on the screen. So we can see that we have here a rectangle and the ellipse. The first one, the rectangle is rendered on top, the ellipse in back. That corresponds to the ellipse being here, the code of the ellipse coming first in the DOM, and the code of the rectangle coming second in the DOM. And now this is flipped. Here we have the ellipse on top. So the rendering order corresponds to the order in the DOM, and therefore if you have like a hidden element or something like that, you would need to check your rendering order, or your order of the element in the DOM. Another important concept is grouping. So up to now we've always positioned everything by hand. Like here, for example, we're positioning all of these points by absolute coordinates, 50, 50, 80, 100, and so on. But that is not necessarily super convenient. And so the example, like what you want to do very often is, let's say, for example, you have a bar chart and you want to label the bar chart. You want to put the value of the bar chart next to it. So you use, you position your bar chart, your horizontal bar chart in Y somewhat, and then you would have to calculate the position of the label and then apply the Y again to that label. What you could do instead is you could create like a bar group and add a rectangle and the text to it, and then position them in Y once, and then only worry about the position in X. So we have kind of like a nesting for SVG elements. In this case, I'm using the nesting because, like, if we do something like a scatter plot, our intuition is not a coordinate system in the upper left corner, right? We always think of a scatter plot to be in the lower left, like to originate in the lower left corner, somewhere here. And so writing down those values is very unintuitive for us. If you want to say like this is 50-50, well, we would have to like subtract that from the height or from the distance to our axis and so on. So that's not very convenient. And what we instead could do is we could wrap this in a group element, then do a transformation and flip it around once so that we have essentially we can write in the coordinate system that we like, that we kind of understand intuitively. So here at this point here, let's say let's start at 0, 0. This is 0, 0 here, and then next to that we would have 10. 10. So this is exactly what we would expect. Maybe it looks better if we do 20, 20. And so what am I doing here? There's two things going on here. There's the group element that essentially packs all of those together, and then I'm using this transformation attribute. And this transformation again is a little bit of a mini syntax. So we have things like translate, scale, rotate, also skew, and so on. So any kind of matrix-based transformation that you can think of, you can do with this transformation element. In practice, we'll mainly use translate, but here I'm also translating it and then flipping it over so that we can use this coordinate system. Anybody can see a potential problem with that? What's it?
A routing shape.
Yeah, if we have certain shapes, it can be problematic.
Oh, well, what if your point goes beyond 200?
Well, then I have to figure something out anyways, right? So this is based on, this translation here is based on the height of the element. So I have to kind of synchronize this. And like if I write this in JavaScript, I would have a variable or something like that. Well, one other problem is that this also applies to text. And this is how they read text in Australia. Not really. Of course, this is like a little bit inconvenient, and so in practice, it's not the best, not the best solution. But it clearly shows what we can do with this translate attribute. Okay. So this is kind of like what I wanted to cover in terms of content today. And now, if there are any questions, I'm happy to take them now. But otherwise, I would go back to our exercise. Yep.
I have a question about the transformation of the group. Does the order of your translation and your scale of those transformations matter?
Yes, it parses from right to left.
Okay.
There is, yes, it does matter. Of course, it depends on what you're doing to it, but it parses from right to left. And there is somewhere here a link to the details. Yeah. So you can look up the details of everything that is possible on the MDN here. You can do like rotations and so on. Any other questions? So this should essentially give you all the skills you need for the first homework. As I said, this is very, very simple. It shouldn't take you more than half an hour if you've ever used HTML before. If you still need any help, there will be a tutorial tomorrow at 6 p.m. in L110 or 101, one of the 110. So across the hall from here, where Carolina will introduce this, and then there is linked from here is an exercise that we will essentially do tomorrow in this tutorial. This is of course completely voluntarily. If you feel like you can complete this homework by yourself, there's no need for you to come unless you want to hear what else Carolina has to say, of course. But this format will be, I think, more interesting once we start getting into a little bit more nitty-gritty JavaScript things. Okay, any other questions about HTML?
Could we use the CSS on SVG elements?
You can use styling on SVG elements, but it is different syntax. So, like you would have things like background color in HTML, but you would have fill in SVG. So this is a little bit annoying, but it's not hard to do in practice. Yeah?
So for homework 1, you want us to include the styling, the CSS styling inside the HTML file?
I think the homework instructions are specific, so I just would recommend that you follow what are in the instructions. I don't know exactly, I don't remember at this point what we put in there.
So what is the solution to the part where the text also inverts when you translate it?
Not use the so like the problem is not the translation, it's the scaling.
This is here,
Yeah. So not using the scaling is the solution to that problem. Yeah. Or yeah. So you'll have to do a little bit of like math. It's still not hard, but any other questions? Okay, so then let's take a look at where we left off with the design critique. Who remember to bring their sketches? Like your redesigns? So let's take 5 minutes and then work a little bit more on your redesigns, like have 3 different versions. A redesign of this chart. I'll come around and then we'll discuss a professional redesign. I brought paper again if somebody needs any. Okay, so yeah, I didn't bring any sheets. Maybe you can sit with somebody who has any of the instruction sheets from last time. So what we did is we did this chart and did an analysis of whether it's visualization or not. And we came up with reasons why it's good or bad. Now you're supposed to create an alternative design using the same data, 3 different designs. So there's some reading on your approach. But I would recommend you sit with somebody who has the instructions and who has the You have to be properly enrolled in the Internet database. That is something that I don't really have to do manually. I'm not done for a single person yet. But let me know if you don't. Like, when did you enroll? You still can't access the. What do you see when you go to your campus? So there's something wrong with your enrollment then. So what your CS yeah, maybe send me like what the system tells you, but also maybe talk to anybody like your advisor or something like that. I can add you. I can also add you by email address. But it shouldn't be necessary. If you did homework 0, then you will okay, there's a homework 0 that you need to complete that kind of introduces all these concepts like this yeah, there's like and then you could there's a link from the here, this link. And then it finds all the homeworks here. This is homework 0. This is like sign up, class array, introduction. And then homework 1, you have to submit that by Friday.
So you have
Oh, I see.
by size or
Okay, we have a shared designs.
And if anything, we can also change it to blocks like that. Also, like one of them, this is by size. There's another one These should all be used to all of these.
Okay, so I've seen a couple of nice designs here. Do you wanna explain that?
Yeah. Okay, so it's not that great. It's pretty basic. So I thought like the graph that was being shown, the one that we are referring to, has 4 portions of information that it is presenting. Like one is the percentage, whether it's like if the disease is in growth or in like it's going down in percentage. One is the actual value, like how many people are dying every year from the disease itself. One is the name of the disease, and the other one is the classification of the disease, like we know there are 3. So like it's a basic 2-dimensional graph. In the y-axis, I showed the percentage, whether it's going up or down, instead of actually showing the number itself, like 1% or minus 1%. In the x-axis, I showed the absolute count of death. And as you can see that there are circles, and like beside them there is name of the disease or the cause of death and the classification by the shading or the color, like if it was something colorful. So the circle would be bigger and would be more right and up if the percentage, if it's growing, and if the count of death is high, and it would come down if the percentage is decreasing, and it would move left if the absolute count of death is like low.
Okay, cool.
So
Thank you very much. So then we have this one here. Do you want to briefly explain that? Or would you rather explain the other one? So this looks like a pie chart, but the size is proportional to the big categories, and then we have the segments in here that represent the relative sizes. I found this one very interesting. Do you want to say something about that?
So it just shows increasing and decreasing on both sides. And instead of putting the entire name of the disease inside it, I just have like a table that shows D1 is this. And all the blue stars signify the ones that are cancerous diseases. And
So how do you visualize the change here?
the change is the 1%, the 1, 2, 3, and -1, -2, and -3. Each one.
Okay, so essentially what we have here is two stacked bar charts, right? And then you additionally encode the change with this nested bar chart in here, which I think is a pretty cool idea. Thank you. And then one more. Yes.
Sorry, it's not finished yet. But what I tried to encode there was a length to be the angle change, and the width of the bars could be the importance of indices. So we would have thicker and thinner bars, and there are 3 bars for the yellow, the green one, and the. Scroll down a little bit.
Okay, and so how do you encode the absolute values of the life lost? Like this is great for change, right?
Yeah, it's by the thickness.
By thickness?
Yeah.
Ah, okay, got it. Okay, great. So now I'll be handing out.
I had one where I told you use colors as well.
It's not going to work that fast.
If somebody cannot see distinction in colors, just kind of
Yeah, let's see how long it takes to sync to my computer. Yeah, I'll hand this out while we're waiting. What you see here is, this was a chart that, because Bill Gates endorsed it, it got a lot of like noise on Twitter. And then a guy called Stephen Few, who is like a visualization consultant, he's this like a very old school, very minimalist person who is like business analytics mostly. And so he created a long blog post about why this chart is terrible and how it could be done much better. And so this is his solution. Could you help me hand this out? And so you guys can take a look. Oh, sorry. Is there any leftovers? Sorry. So let's look at this chart. So how is this chart different from the one we saw before?
Specifics of the information spread.
One of the other, and please speak up.
Specifics information in separate distinction. I think you can easily look in and get the specific value. At the same time, get understanding of
Yes.
trend analysis.
So we have 3 columns. We have the years of life lost per 100,000, the percent change, and the death per 100,000. So all of these 3 variables are very clearly separated. What's the advantage of that? Like we can.
From this I can't figure out which get story is bigger.
You can figure out which.
Which color is the most?
That is true. So you don't. What you lose here is the total, like a visualization of the totals.
No, that's at the top left.
But exactly, there is an additional little chart here where he simply puts a table up there. But yes, there's a valid criticism. It's not immediately obvious. You have to read this more closely. So what other thing did he do here that wasn't done in the other chart? So, yep.
You get the exact percent changes.
Exactly, you can read the percent changes very clearly. So you can see that other communicable diseases, meningitis and hepatitis, decreased more than 30% in the last 5 years. So that is essentially, like all of these gray ones here is what Bill Gates was talking about, that there is progress being made in these communicable diseases that, being addressed in developing countries. Where do we have an increase? This is injuries other than accidents and self-harm. So there is like an increase in changes of year life lost, and then we have an increase in neurological disorders, stroke, and diabetes, and like blood disorders. Another thing that wasn't in the original chart is this distinction between death per 100,000 and years of life lost. And the point here is mainly that there is a difference between, like, everybody dies eventually for some reason, but there's a difference if I die at 105 of like heart failure, or if I die of malaria at 25, right? There's a different impact on society, and so instead of like having absolute number of deaths, what he does here in this chart is he adds this derived value of years of life lost per 100,000. And so we can see here, for example, that the most common cause of death is actually heart disease, but it is not as important in the years of life lost. Whereas neonatal and maternal disorders, they are very small in absolute numbers, but in terms of years of life lost, because it mainly affects babies, they're quite significant. And so it depends on the question that you want to ask, what is the more important thing, but in practice, you mostly care about the years of life lost from a public health perspective. So, compared to the other chart, which one do you prefer? And because?
It's more informational.
Yeah. But what do you think if you saw a chart like this in, like, say, the New York Times, compared to the other one, or in a magazine at a coffee table? Yeah, it's simpler, it's boring, it doesn't draw your attention as much. Okay, great. So let's conclude the class for today.
I have a question about this, because this particular graph didn't have the information you need to kind of segregate between less than 100 and the other side loss. You want to get the information.
You calculate, like he probably used another data source. Yeah, but there's a link to his blog post, and I'm sure it's explained there, like in the second sheet. Okay, well, next Thursday we'll have a theory lecture, and then on Tuesday we'll have a code lecture again. I'll see you then.